I say create index, okay, it will create a secondary index subtable on, just a second. It will create a secondary index subtable on each and every amp of the system. So secondary index generally consists of 3 columns. Okay, it's going subtable is going to have 3 columns.
Okay.
The middle column is going to be of the secondary index column value. Means whatever be the value that was existing on which the secondary index has been created, all those values will be stored in the secondary index column.
Okay.
Okay. In the second, what are the values in the secondary index column? Those values will be stored in the middle column.
Okay.
The first and third rows, third columns of the table will store the row IDs. So first column is going to be the whatever be the value in the secondary index column. For that value, whatever be the associated row ID for that. For that column, if I pass that particular value to the row hashing algorithm, whatever be the row ID that it will give, that value will be stored in the first column. It means that the first column is going to hold the secondary index column values row hash or the row ID.
Sorry, Sajna, can you please come again?
Yeah, sure. So here I am storing. If you see here, you can see the value 74 in the cust column, right? Here, the user is creating the secondary index on customer table. Secondary index is created on cust column, customer ID.
Okay.
So if you see here, there is a value 74 in the cust column, right?
Okay. Okay.
So if I pass this value to the row hashing algorithm, whatever be the row ID I'll get for this value 74, that value will be stored in the first column.
Okay.
If you see in the base table, these are the topmost is the secondary index subtable. So if you see in the base table for customer ID 74, what is the value you can see here is 74. You can see the name as Smith here, right?
Okay.
Smith, and the primary index for this is phone number. It's a non-unique for primary index, and the value is 5556666, right?
Okay. Okay.
So if the value 5556666 is given to the row hashing algorithm, it will get some row hash value and the uniqueness value, right? So
Yeah.
whatever be the uniqueness row ID, whatever be the combination of row hash and uniqueness value, which we are calling as row ID, the row ID will also be stored along with the data record on the system, right?
Okay.
So associated, whatever with the associate for custom 74, whatever with the associated primary index columns row hash value will also be stored in this here. What is the associated value for 74? Associated primary index value is 5556666, right?
Okay.
So for this value, whatever with the primary index that was not primary index, row hash or row ID that was there, it will be stored in the third column.
Okay.
So
So
in the
basically, the
subtable,
subtable is
yeah, go ahead.
subtable is something like an intersection table kind of thing to
Sorry,
some extent. So I can consider subtable as like an intersection table kind of thing.
not intersection. Why it is storing is I'll tell you. So it is going to store 2 row ID columns and 1 column which is going to hold the secondary index column value. First row ID is going to be the value row ID of the customer column, and whatever with associated primary index is there, right? That associated primary index row hash will be stored in the third column. Why it is storing? What is the necessity of building this table? If I'm accessing the table on customer column, cust equal to 56 here. If you see in the slide itself, he is firing a query like select star from customer table where cust equal to 56.
Okay.
So when the optimizer observes this query, it will come to know like the cust column which is there in the where clause is defined with secondary index.
Okay.
right? Here they have created unique secondary index, right? So it observes like this column is secondary index. So when this is passing this value cust equal to 56, this value will be passed to the row hashing algorithm.
Okay.
Okay, secondary index value it is passing to row hashing algorithm, and it has given a value of 602 as the row hash value.
Okay.
So rather than pointing to the base table here as the indexed column that was used in the where clause, it is a secondary index column. It will point to the base table rather than the, sorry, it will point to the subtable rather than the base table. The reason why it is pointing to the subtable is the index in the where clause is secondary index.
Okay. Okay.
Okay,
Okay.
602 is the row hash value. The value is 56. It will double check for is this the value in the where clause is 56 or not. Yes, and the row hash value 602 is same or not. It will cross check, and here it is able to retrieve the 778 comma 7 as the primary index columns values row hash. The primary index record is row hash value is 778 comma 7. If you are aware of the row hashing algorithm and row hash value, you can easily find out the AMP where the record is existing, right? You know
Yeah.
the row hash value. From row hash value, you need to query the hash map, which will give you the bucket and which will have the AMP number, right? So
Yeah.
778 comma 7 is there in AMP4 where the base table is recording is existing. So how many AMPs you are accessing? Here you came to AMP2 where you queried the subtable record, and from there you queried the base table record from
Correct.
AMP4. Out of 4 AMPs, you are eliminating AMP1 and AMP3 from processing, right or wrong?
Correct. Correct.
So the purpose of the index is to eliminate maximum number of records from processing.
Okay. Okay.
So here it is not at all touching the records of AMP1 or AMP3.
Okay.
And in
Okay.
AMP2 and AMP4 also it is processing only certain set of records,
Okay.
right? So that is
Correct.
how it is increasing the processing speed. If you are using a
Okay.
primary index, it's a one AMP operation. But here I'm not using the primary index. I don't have the option of using the primary index. So I am using a secondary index column in my in my where clause. So rather than a full table scan, it is better to have a 2 AMP operation like that, right? Because I am at least eliminating some of the records. Whatever be the number of records I am eliminating from the processing, that is the amount of time and resources I am saving on behalf of. I am saying that is the number of records and that is the amount of time that is going to take. That is the saving from my end on the system.
Got it. Okay.
Clear?
Yeah.
So
Got
that
it.
is how the system resources will be saved and the processing time can be reduced whenever you are using the secondary index. Of course, the primary index is the best one in terms of performance. But
Okay. Okay.
the purpose of the index itself is try to avoid the as many number of records. Here, whatever the records on AMP1 and AMP3, it has totally eliminated from processing. From AMP2 and AMP4 also, it is eliminating maximum number of records. It is only accessing a certain block of records that was
Okay.
having this row hash values. Rest
Okay.
of the blocks also it is going to eliminate from the processing. So if you say here, how can I say like the rest of the blocks are eliminated from the processing, right? Here I am saying on AM2 and AM4 also, it is eliminating maximum number of records. Only it is going to process the block that is holding these records. So how come it is going to identify that these are the blocks holding the records with this particular row hash value? What is the scenario? How the from row hashing algorithm I am able to identify only this specific record is the question, right?
Uh-huh.
Records
Yeah.
are stored in the blocks. That's what I was saying. How it is going to identify the block with the record that is having the value of customer 56? How it is going to identify? Means you can see, right? You can say like there are n number of tables on the system, and there could be millions of data blocks. Out of those blocks, how it is going to identify the block of the customer table, and out of that blocks that were used by customer table, how it is going to identify the block that is having the value 56. So coming to
Okay.
this, whatever be the data or the memory that was there on the Teradata AMP, right? Out of the amount of space, let's say we have 1 terabyte of space, and here we are having 4 amps, right? So 1 terabyte by 4, what is the space it is going to be? It is going to be 250 GB of space per amp, right? 1 terabyte divided by 4. So per amp it has got an allocation of 250 GB because it will be equally distributed. Do you agree for this, Rajesh?
Yeah, yeah, correct.
250 GB
Hello.
per amp has been allocated. So
Yes, correct.
all the space in Teradata system will be in the form of the data. Minimum chunk of the data will be in the form of blocks. It will be of 512 KB blocks. A block will be of size of 512 KB. In general, it may be of bigger size. It depends on the system settings. But in general, the data block could be of size 512 KB. Okay. It depends on the server settings again. So in general, if I am saying 512 KB block, the group of blocks are grouped into a concept called cylinders. A set of blocks is grouped into a structure called cylinder. So the space in Teradata system will be in the form of cylinders. If the data is written to any of the blocks, those are called as used cylinders, and if the blocks in the cylinder are empty, it means not even a single record has been written to any of the block, means entirely free and are ready for use. Those are called as empty cylinders or free cylinders. Okay. So all the used and unused cylinders in Teradata system will be tracked by the system. Okay. All the used and unused cylinders in Teradata system will be tracked. So who is going to track this used and unused list of cylinders? Okay, that is the question. Here in Teradata we have a concept called master index. Okay, so we'll go by a general example. You are going to write a board exam. You are from BTech or from MCA background?
BTech.
Rajesh? BTech.
Yeah, I'm
Let's
from
say
BTech.
you're
Yeah.
okay. You are going to write your BTech exam, and you are allocated with a particular examination center, and your roll number is 10 or 7. Okay, your roll number is 7. So for every examination center, it will
Okay.
have certain examination code, center code, right?
Yeah.
So how will you go to your center? How you know this is your center code? In the hall ticket, they will mention like there are n number of centers in the city, and out of that you have reached to your allocated examination center based on the code, right?
Okay.
Based on the university assigned code, you will reach to the examination center. So what you will do after that, you will check in the notice board bulletin where the rooms are information is displayed, right? On the
Correct.
notice bulletin, it has displayed like roll number starting from roll number 1 to 10 should go to room number 1, or will it be like 1 2 3 4 5 6 7 8 9 10 will be 1? Will it be like that, or it will be range bound basis 1 to 10 to 1, 11
Yeah,
to
it will be
20?
1 second.
It will be written as a boundary basis, right? 1 to 10 room
Correct.
number 1, 11 to 20 room number 2, like that it will be
Correct.
written, right? So your examination, sorry, your roll number is 7. So which room do you need to go? Room number 1, because 7
Okay.
is in the boundary of between 1 to 10, right?
Correct.
So you reach to room number 1. So in the room number 1, there are two rows, two columns, with the seating arrangement. On one side it is having some chairs, and on the other side it is having another half of the chairs. So 1 to 5 on one side, 6 to 10 on one side. So your hall ticket number is 7. So how will you check? will you go and start checking from first chair, starting from roll number 1, or you will directly go to the other side of the row?
Directly go to the other.
So you are, why you are not checking? Because your roll number is falling in the second half, right?
Correct.
In that second half also, will you start? Will you go and check till the last number 6? This is not my number 7. Even though it is your number, you will not stop and you will keep on checking like that.
No, no.
You will eliminate in that second half also. You will not start searching from the last. In the first half, in the left side half also, you'll start only in the first half of the chase, right?
Correct.
So similarly here also, there is a concept called master index and cylinder index. Okay. So master index is like your university, where it will track each of the examination center by a center code. Okay. It is
Okay.
like your university, where it will track, doesn't track by the college name. It will track by means of center code, right? So
Okay.
in terms of the system, so what are the tables we are using? Here I am saying financial.test20, right? When I create
Okay.
a table with the name, with a certain name, it will allocate a unique number for the table, because the system can't able to identify by the human readable name. It will identify everything by means of a number or a token mechanism, right? Here
Okay.
the every object you can create, whether it can be a table or it can be a view, whether it can be a database or it can be a user. For everything there is a unique object ID that will be assigned. See here, for database it has database ID. These are the list of the tables. For every table there is a unique ID. Database is having its own ID and the object is itself is also having a unique ID. Okay.
Okay.
Like
Okay.
that you will be having a unique ID allocated to each of the object. So whenever you mention that particular table in your query, it will be identified by the object ID allocated for it. If you see here, you can see the table ID 100. You can
Okay.
see it in the on the slide, right?
Yeah.
Along with the row hash and the secondary index value, it is also passing the 100 as the table ID.
Okay.
So the system is aware of the object ID that has been allocated to the object which you are referring in your query. Now you need to pull the list of the cylinders that were consumed by the table. If you are inserting the data into the table, you are inserting the data. It is filling up the blocks, right? You are
Correct.
filling up the blocks means you are consuming the cylinders, because cylinder is nothing but collection of data blocks, right?
Correct.
So now you need to find out the list of the cylinders that were used by the customer table. You are having n number of tables. Out of those tables, you need to find out the blocks that were consumed by customer table, right? So it
Yeah.
will query the master index. Master index is the one that will keep track of all the cylinders in the system, whether it can be used cylinders or free cylinders. So whenever the master index is queried by this object ID, it will get the list of the cylinders that were used by that particular object. So here, whatever be the custom cylinders consumed by the customer table, when the object customer allocated object ID is queried on master index, it will give the list of the cylinders that were consumed by the customer table. Okay.
Okay. Okay.
Now you have the row hash value, right?
Yeah.
Getting the list of the cylinders is getting the list of the examination centers. Now you need to reach to your code. You need to reach the block where the record is existing. Means you need to reach your examination center. So whatever with this row hash value, for every cylinder there will be internally a cylinder index. This cylinder index will keep track of the records or the blocks that were having the records. So all the records on the AMP will be stored on a ascending order of row IDs. If you notice here, there will be order 107, 536, 638, 640, 471, 555, 717, 884. The records are in a sorted order on the AMP based on row ID. You can observe here,
Yeah.
right?
Yeah.
Even in this case, 224, 505, 744, like that, right?
Okay.
The records on the AMP will be stored on sorted order. You may also think like, why they are creating a unnecessary pressure on the system on sorting the records, right? The insertion itself will take time, but keeping those records which we are inserting in a sorted order is also a tedious process, right? If the record is coming up in the middle, you need to adjust the records and you need to insert it in the middle, right?
Correct.
Right or wrong?
Correct. Correct.
Right? So why
Yeah.
they are doing this kind of unnecessary overhead on the database means it is for a specific reason. So here you know the row hash value. Your examination number is 7, right? So all the roll numbers were arranged like starting from 1 to 10, room number 1, starting from 11 to 20, room number 2. If you consider the roll numbers as the row hash values, starting from row ID 1 to row ID 20, the records are in block number 1. Starting from row ID 11 to 20, records are in block number 2. Like that, in order to maintain that particular perspective, the records are stored in the sorted order. So in the cylinder index, it will maintain the row ID values. Whatever be the starting and ending row hash values for each of the block, those records will be maintained in the cylinder index. So if I say the row hash value is going to be 602, so whatever be the interval in which the row hash value will fall, that particular block is the one that is going to be accessed. The rest of the blocks will be eliminated from processing. In that block also, it's not going to do a sequential search. It is going to apply a algorithm called binary search. Are you aware of binary search algorithm?
Yeah. Kind of remember.
You might have heard it, right?
Yeah.
So what is the algorithm that you have applied in finding out your seat number 7 is the row hashing algorithm. The precondition for binary search algorithm itself is the list should be in sorted order. That is the reason why the records on the AMP are stored on ascending order of the row ID. Clear? Why it is taking that particular overhead means the records
Correct.
on the AMP will be stored on row ID, will be stored on the order of the row ID means because in order to apply the binary search. So within the block you have find out the block where your row hash is fitting into, means 7 is your row hash value. So 7 is falling in the interval of 1 to 10. So whatever be the block that was holding the record from 1 to 10, that is your block where your record is existing. So rest of the blocks it is eliminating from processing. Even though it is doing a 2 amp operation, in that 2 amps also it is only processing a certain block of the data, but it is not touching the rest of the blocks. Clear?
Yeah. Got it.
Okay. So it is here in case of a unique secondary index. First, it will come to the base subtable index subtable. From the index subtable, it is acquiring the primary index row hash value. Based on this primary index, it is coming to the base table. So how many amps it is processing? How many
No.
amps it is processing here? 2 amps.
Yeah.
One is base table, subtable, then to the base table, 2 amps.
Correct.
Here I am saying as the index, secondary index is a unique secondary index, right? Unique secondary index means how many repetitions of that particular value will occur?
None.
Only one value. So the number of records that are going to be part of the output is either
Yeah.
0 or 1. If the record exists, the value, the number of records that will be part of output will be one record.
Yeah.
If there is no such record, it's going to be 0 records, right?
Okay.
0 or 1.
Yeah.
If the
Correct.
record with 56 exists, you will get the record, one record. Otherwise, it will be 0 records.
Correct.
So why it is going for it subtable and base table? The reason is the records are distributed by means of primary index, right? So it's not going to impact the thing. So what is the concept of non-unique secondary index then? Non-unique secondary index means it will itself is saying that there could be duplicates with the same value, right? There could be duplicates with the same value, right or wrong?
Correct.
Non-unique.
Correct.
So I'm going to allow duplicates in the secondary index column. Here also the same customer table, but this time the secondary index is created on customer name. So there could be n number of people with the same name. Okay. There could be same name, people with there could be a number of people with the same name, right?
Yeah.
So
Correct.
in that case, in general, the data will be distributed on primary index, right? So there could be a possibility like there could be the value which was defined with non-unique secondary index, and the value could be exist on every AMP in the system, right? If
Correct.
you see here, the name, the customer name is the one that is defined as non-unique secondary index, and user has filed a query saying name equal to Adams. If you see here, the customer with the name Adams is there on AMP1, AMP2 also there are two records, right? If there is a record with Adams on AMP3 also, so it can exist, but they cannot exist on the same AMP, right? Because the data is distributed on primary index but not on secondary index. Clear?
Correct.
So there is a
Correct.
slight difference in terms of arrangement of subtable records. Okay, there is a slight difference in terms of the logic how the subtable records will be stored on the will be stored. So what is the difference and why it has been kept like that in case of non-unique secondary index? We'll see now. So the basic logic behind the maintenance of the subtable records in a non-unique secondary index is wherever the wherever the base table record exists, the subtable record should also exist on the same AMP. If the base table record with the name Adams is existing on 4 amps, the subtable record should exist on 4 amps. So does it mean like is it getting duplicated? Means they may not be the same records because it is differing by row hash value. Will they be the same records? No, right? The reason is they will be same in terms of row hash, but they are differing in row. They may be same in row hash, but their uniqueness value will be different. So on the whole, the uniqueness, on the whole, the row ID is going to be different, right?
Correct.
So if you see here, Adams is the one that is stored on this subtable. Here also you can see the Adams, and the associated row ID of this is stored on the subtables. Here, as it is having two records, it is storing those two associated primary index row hash values also. So why the design has been kept like this in case of non-unique secondary index? Why they are not maintaining all these records on a single app? That may be the question That may be the question that will arise in our mind, right?
Yeah.
As due rather than maintaining this one as on all the amps, why don't they maintain all of the records in the same amp? Could be because
Correct.
of two reasons. It could cause a skew, right? It
Yeah, that
could
is
cause a
true.
skew. Subtable will get skewed, right?
Correct.
And the other thing is there are some bulk loading utilities in Teradata system. There is a bulk loading utility in Teradata system that will support non-unique secondary index while loading. Okay, that will support non-unique secondary index while loading. See, whenever you insert a particular record into this customer table, it will insert the record in the base table as well as it will also insert a record in the sub table, right? Because the
Okay.
subtable information is also need to be maintained. So you will
Correct.
think like, yeah, I am inserting only one record, but internally it is inserting two records, one into the base table, other into the sub table,
Correct.
right? So whenever the bulk loading utility is loading the records, as it supports only non-unique secondary index, if it is loading the record into AMP1 and the subtable is record is going on to a different AMP, it will be a bit problem and it will reduce the speed of the loading utility, right?
Yeah.
So because of that consideration, it might have been kept like this.
Okay. Okay.
Okay. And also to avoid the skew also, the table may also get skewed. Okay. So
Correct.
that is
Correct.
the reason why wherever the base table record, if the base table record exists on AMP1, its associate subtable record should also exist on AMP1. If record exists on AMP2 also, its associated subtable record should also exist on AMP2. Like that, it's referring in local with respect to the subtable record in case of
Non-unique secondary.
non-unique secondary index. So when
Okay.
I am saying non-unique secondary index, let's say the base table, the record with the name Adams is existing on all the four amps. Okay,
Okay.
I have four amps in my system, and the record with the name Adams is existing on all the amps in the system. Means the subtable record will exist on all the four amps, right?
Okay.
Now you can say you may think like, okay, as the record is there on all the amps, so there will be a subtable will record will also exist on the same on all the amps, right?
Yeah.
So it is an all amp operation. So it is going, you may think like it is an all amp operation, so it is processing all the records, right? As it is a all amp
Mm,
operation, right? It is processing AMP1, AMP2, AMP3, AMP4.
but again, the it won't be processing all, right? So it will.
Yes, exactly. The thing is, even though it is processing all the amps, it is touching all the amps. You can say the non-unique secondary index is an all amp operation or an amp operation, but it is not a full table scan. The worst case is the full table scan. In case of this non-unique secondary index, even though it is an all amp operation, but you are not going for a full table scan here, right? You are
Yeah.
only processing a certain amount of blocks where these subtable records are existing, right?
Yeah.
So
Correct.
at least even though if there are 100 records, if you are eliminating 40 records from processing, so you are at least saving the time which is going to be spent on that 40 records, right?
Correct. Correct.
So you are eliminating the full table scan. So rather than a full table scan, it's better to have a non-unique secondary index by search. Rather than a non-unique secondary index, which is a all-amp operation, it's better to have a secondary index in terms of performance. Rather than a secondary index, unique secondary index, it's better to have a primary index. So primary index is the first one that is going to be good in terms of speed, in terms of the retrieval. After primary index, it is best, the best is unique secondary index. After unique secondary index, a little better is non-unique secondary index, and the worst is full table scan, which is going to process each and
Very good.
every record in the table. So if you are not specifying whether the primary index or secondary index columns in your where clause, whether they can be unique or non-unique, if you are not specifying them in your where clause, you cannot use the capacity of the index. Index purpose itself is to eliminate the maximum records or the unmatched records from processing. If you are not using them, the system on its own cannot use the index. You need to refer them explicitly in your where clause or in your join conditions.
Uh,
Otherwise, if you use any of the non-indexed columns in your where clause, it's always a full table scan. Yeah, go ahead with your question.
yeah, so let's say I want to take an extract. Okay, so I want to take the complete dump of the customer export. Let's say I have some 10,000 records. I want to take a complete extract. So in that case, I will not be specifying any var clause, right?
If
So
you want to specify like select star from customer table, what does
yeah,
it mean? You are intentionally doing all the records retrieval from the table, right?
correct, correct.
Then it's a full table scan only, right?
Yeah, so I mean, so is there any other way with mentioning the indexed column alone in the select query? Will that help in performance?
Just a second, let me switch off my fan. Yeah,
Yeah.
now go ahead with your question.
Yeah, so now what my question is, let's say I want for my customer extracts a report, I want to extract all the customer data. Let's say I have some 10,000 records of customers. So
Okay,
they are asking me to extract the complete list and then send it to them. Okay.
okay,
So now, ideal scenario, I would do select star from customer, extract it out. So let's say this
customer table.
operation is, yeah, so let's say this operation is taking like 20 minutes of extraction time. So
Okay,
is there any way like, I can, kind of fine tune this, like just mentioning the index column in the select clause or, manipulating like that? No. Hello. Hello, Chaitanya? Hello. 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 Can you hear me?
Rajesh?
Yeah, taken. Hello.
Yeah, it's audible, right?
Yeah, now it's
Yeah. Yeah, you are saying like you are dumping the data by means of select star operation. Of that, I didn't get what you. Can you
yeah.
come again?
Okay. Yeah. So for the required for data extract, I was told to extract the list of customer data. So now
Okay.
I'm doing select star from customer.
Yeah.
Let's say the operation is taking 20 minutes time.
Okay.
Okay. So now, is there any way for me to, fine tune and, optimize the time, like by using the indexed columns in, maybe select statement or something like that, so that it
See,
reduces to 10 minutes?
see, if you are selecting the data on columns, 10 columns, but you are not doing any filtration, right? You are dumping
Yes,
whatever the 10,000 records, you are dumping all those 10,000 records, right?
yes, correct.
So if you are not filtering out, how come it will be possible to have it a bit more quicker? You need to cut short. See, in those cases, if you are reducing some amount of the data based on the volume or the record size, it may be a bit quicker. But in terms of on the whole, if you are seeing, that doesn't make much difference. Suppose if you are having 1,000 columns and if you are only accessing 10 columns, that may
Okay,
differ. But in terms of to be practical in scenario, if you are selecting all the columns and all the records, it's not going to change anything. Because
okay,
if you are eliminating some records, means then only you can able to save. You have started your journey from Hyderabad to Bangalore, and it is, let's say it is of 600 kilometers. And on what case you will be seeing it in a faster manner? How come in general it's going to take, let's say, 8 hours? Okay. So on
okay.
what factors you can able to reduce the journey time? Is it possible? On ideal road conditions itself is 8 hours. On a free road, so is there any possibility on
Mm,
to reduce it in ideal case? No, right?
no.
Without filtering the data, if you are asking it like, yes, it may be possible if you are launching your particular, let's say you are triggering it from a tool. Okay. Yes,
Yeah.
it may possible if you are launching it with more number of sessions. Let's say you have 100 amps. If you are launching your job with 100 sessions, for each session is working on each of them, then it may be faster when compared to 10 number of sessions. Okay. But because
Okay.
of that, other sessions may impact. Increasing the sessions is not a good thing, but in terms, to be frank, on ideal case, it's not possible.
Okay. Okay.
Okay. Clear?
Yeah. Yeah, I got it.
So clear with these things, right? What is a unique secondary index and non-unique secondary index? What could be the possible way of arrangement? How many amps will be involved in processing?
Yeah, got it.
Sure.
Yeah, yeah,
Okay. So we'll do out a matrix now. Okay. We'll
yeah.
keep a matrix of what we have seen now till now. Unique primary index, non-unique primary index, unique secondary index, non-unique secondary index. Okay. These are the indexes that I'll be using now in my where clauses. So if I'm using these particular things, how many amps, number of amps and number of records will be part of the processing. So if I am using a unique primary index in my where clause, so how many amp operation it is and how many records will be part of the output. You need to fill this matrix now. So if I am using a unique primary index in my where clause, how many amps will be involved in processing and how many records will be part of the output?
So unique primary index will be it will be a single amp operation,
Okay.
and number of records will be only one.
Number of records is going to be 1.
Yeah.
And if I am using a non-unique primary index in my where clause, so how many amps will be involved in the processing and how many records will be part of my output?
Again, it will be one amp.
Okay.
And the number of records can be multiple because it is
N
non-unique.
records.
Yeah.
It can be N, whether it can be
Yeah.
0 or 1 or 2 or 3 or it can be anything.
Okay.
Okay.
The first one it can be either 0 or 1 number of records.
Yeah, it can be 0 or 1.
You
When I
need
am
to
using a
retrieve digit
unique
2.
secondary index, okay,
Yeah,
2
it
amp
needs to.
operation,
And
number of
here,
records,
not unique secondary index.
number of
Again, can
records
you
in the output,
0 or 1?
sorry,
0
0
or
or
1.
1, exactly. If I am using a non-unique secondary index in my where class,
N.
how many amp operation it is going to be?
It may be all.
All of them.
N.
Or you
Yeah.
can also say it as an amp operation.
Yeah.
Okay,
Again,
better
number
to
of
say it
N.
as all amp operation. Number of records,
N.
1 or N?
N. N.
1.
N. N. N.
1.
N. Number N.
Okay, N. Okay. So this is the matrix you need to remember in terms of the indexes. Okay.
Okay.
You are the first person I have seen in all my sessions who has given out this matrix exactly. Everyone will get confused here saying that non-unique primary index. Okay. Non-unique, right? Multiple records. All amp operation. Unique secondary index, they'll say like unique primary index is 1 means, so they'll say unique secondary index also has 1 amp. They'll get
Yeah.
confused with a non-unique, right? So a number of values, so it's an all amp operation. That's the thing they used to get confused.
Okay. Okay.
Good catch. Okay, so this is about our indexes.
Okay.
So
Okay.
we'll see the next thing is in terms of here when I'm creating the table,
Mm-hmm.
I'm using certain terms here, right?
Yeah.
Like create set table, create multi-set table. So what is the set table? Are there any types of tables? If I don't specify it as set, what is the necessity of setting set? Or is there any other things also? Are there any other different kinds of tables available? And why I am specifying this fallback? What is the necessity of specifying the fallback? What are these journals? All these things we need to know. Even though it is a standard, if you are not specifying this set table, if I'm not specifying any of these things also, it doesn't matter. Whatever be the default at system level, it will consider. But you need to know why they have been kept. In some environment, they may not be the default. Here my default is no fallback, no before journal, no after journal. Of course, 99.9% of the cases it is going to be no, but in some cases, or if you create by mistake with a fallback or with journals, what are the issues it is going to cause? All these things you need to know. Okay. So before going into that, you have seen the secondary index. So what are the advantages and disadvantages of secondary index? Advantage is it is reducing the skew factor and it is speeding up the retrieval process. Right or wrong? Right? If there is an uneven distribution of the data and the data retrieval is slower,
Right.
right? So in that case, you are able to increase the speed of the retrieval using the secondary index. Okay. So what could be the ideal candidate for secondary indexes? All these things will be the same like in case of primary index. Better to choose the secondary index column, whatever be the frequently accessible column, right? It will be better if you choose that type of columns as a secondary index, because the reason is if you choose a non accessible column means whatever the less frequency of a column if you are choosing that particular column as a secondary index column, you are unnecessarily wasting the space. If I am not using a proper column as a secondary index, if I am creating a secondary index, you may get a question like how I am wasting the space. Okay, to a certain extent you may think like, okay, I am doing a full table scan, but how I am going to waste the space? That is the question. That is the question that may come up in your mind, right? So how you are wasting a space whenever you are creating unnecessary secondary index means whenever you create an index by means of create index command, it is going to create a secondary index subtable on each and every app, right? And it's going to populate with the records, right? If you are creating a secondary index, whatever the subtable that is going to create, it is going to consume the space on the disk. So in Teradata, the costliest thing is space, right? In Teradata itself, the costliest thing is the space. So if you are creating the secondary index unnecessarily uh, on the columns that are not required, will result in unnecessary wastage of space. Okay. So you need to be choosy when creating a secondary index because it will result in disk space utilization. And one more thing is if you are creating unnecessary secondary indexes, even if they are not needed on the table, it may result in slower insertions and updations of the data. Why it is resulting in slower insertions of the data? What could be the reason? Because you might, if you are loading 100 records into a table but is inserting 200 records on the system, right? One record into the base table, other record into the index table, right? So it is going to spend some extra amount of time on inserting the base table records, right? So it is going to increase the time that was spent on the insertions of the data into those tables. Clear?
Yeah. Chaitanya,
So
one question I had
yeah,
earlier.
yeah.
So let's say in case of this non secondary index concept, right? So let's say
Mm-hmm.
when they are inserting, it will insert the record in the base table plus the subtable, right?
Yeah.
So in case of deletion also, it will be the same. It will delete this base table entry and
Yes,
the
it will
subtable.
be deleting the records from the base table as well as the subtable, right?
Okay, okay,
It will be
okay,
automatically done in parallel.
okay, okay,
So what generally they will do, what generally the loading jobs will do is during insertion they will drop the index secondary index, they will load it, and again they will recreate it
okay, okay,
because secondary index can be created at any point of time and can be dropped at any point of time if not needed.
okay, okay. Got it. Okay, okay.
Okay,
I guess
so
that is
that is the
even
case.
easier.
Yeah. So you need to be choosy on case of the secondary index because the disk space is a very costlier thing in Teradata. If you send out to add a request to your DBA for requesting for a space, he will not add the space, but he will in return he will reply with a certain number of questions. Why you are requesting for space? How much space is needed? Why you are requesting for this amount of space? To what extent and for how many days you need the space? Like this, you will be getting the questions from your Teradata DBA if you are requesting for space because they need to be very cautious in terms of space because there is no concept of adding a hard disk here. Okay, if it is exhausted with the space, you need to buy a new node which is going to cost you in crores.
Okay, okay,
So that is the reason why Teradata DBS will be very much cautious and they will will send out a questionnaire when you request for a space.
okay, okay, okay.
Okay,
Yeah,
so we'll stop it here for today and we'll tomorrow continue tomorrow same time. Okay, in the
yeah.
morning.
So yeah, tomorrow it will be 7 to 9 again.
Yes, 7 o'clock.
Okay, okay. And starting next week, can we have it only on weekends like Saturday and Sunday?
Why?
I felt it because this whole week when I got up like around 6:45, right, I started sleeping in office after I reached because no, the reason is after 8 o'clock, right? So I stay connected from 8 till 11, and I
Okay.
reach office by around 12. Then again I start from office by around 8 and come back at 9 and stay connected
So
till
you want
11.
only in the weekends.
Yeah, weekend, like even if you want me, if you want like 4 to 5 hours a day also, I don't mind. It's okay for me. But
Okay. Fine. Is it not possible even in the night time, like 9 to
Yeah,
10?
9 to 10 is fine. Like, yeah, early morning is like difficult for me,
Fine.
but 9 to 10 is
We'll
fine.
have a session for tomorrow in the morning.
Okay.
Uh, I'll inform Ram whether so that he may get in touch with the tech people. Okay, we're
Okay.
regarding the timing. We'll discuss it tomorrow. Okay, I'll tell you tomorrow whether when from when we can have 9 to 10 sessions. Okay.
Yeah, sure, not an issue, not an issue. Yeah,
Yeah.
sure.
Okay.
Yep, yep,
Sure.
thank you.
See you
Yep,
tomorrow.
thank
Yeah.
you.
Bye.
Yeah, see you. Bye.
ఆర్కే గారు వాళ్ళు చచ్చిపోయిందా ఎందుకు వస్తున్నాను అంటే ఊపిరితిత్తులేగా శ్వాసకోశ